Hello students, I hope you all are fine at your home. Last time we have started a new chapter, chapter number 4 of unit 2nd. So last time we have discussed about the introduction of the earth structure. So today we are going in deep, okay, structure of the earth. Basically, the earth structure is composed of three parts: crust, mantle and core. You know very well, even in earlier classes you studied there are three structures. Last time we have already discussed with a diagram. So first of all, today I am going to discuss with crust. So what is crust? We know very well the uppermost layer of the earth is called the crust. Generally it is also called the lithosphere. In scientific terms, what is it called? It is called lithosphere. Litho, it means the rock. Now how? Lithos, it is the Greek word. What is it? It is a Greek word and meaning rock. It means the surrounding of the earth is surrounded by rock. That's why it is called lithos. Okay, and that's why the complete layer, the complete surrounding layer, it is called lithosphere. The outer layer is about 6 to 60 kilometer thick. Okay, if we are measuring, now see by this diagram, now this is the mantle. Okay, and if I'm talking about the earth crust is not even. Okay, it is uneven. So that's why maybe in some place the earth crust is very thin, and some place the earth crust is very thick, and maybe in some books it is differ, the data is different, so don't confuse. Okay, you have to write the average data because different books consider different datas. Okay, in some books maybe it is 5 to 48, some books it is 5 to 32. It is a different data, but you take the maximum data, maximum area. Okay, so now it is the thickness of it. It consists of a two layers. Basically it consists of a two layers. Which one? The lithosphere or the crust is also of two. It is a composition of two layers. Basically it is called sial and sima. Generally for the learning terminology you can also learn it is sima. Okay, you can also learn that sial or sahil you can learn by the name sahil, and sima, okay, I hope you can learn by this way. So now you can understand what is this. Generally, the earth crust is of two types: the continental crust and the oceanic crust. What is the continental crust and what is the ocean? Both are same, but there's a different. The crust which is above the ocean, this is the ocean level. Okay, this is the ocean level. The layer which is above the ocean water or above the ocean, so this is called the sea. Okay, and the layer which is under the water, this, now you can see this is under the water, so this layer it is called the sima. I hope it is clear. Now see, that's why this seal is also called the continental crust. What is it called? Continental crust. And sima, it is called oceanic crust. What is it called? Oceanic crust. Now, so you can easily understand by this diagram. Now, in detail, Cr, it consists solid and it is a continental part which I already explained you. Main composition of it is the granite rock. Okay, which type of rock? In the above surface. Okay, we are talking about the Cl. Cl is the above layer. In the lower layer it is called the sima. Okay, so it is composed of granite. Granite layer or the Cl floats on the sima. Yes, downside there is a sima and above there is a see also, that's why it is floating over the sima. In composition, basically, what is this Si? Si and Al. So Si it means silica and Al it means the aluminum. So it is the composition of silica and aluminum. That's why it is called Cl. Okay. Next one, it is the sima or sima. Lower continuous layer, because upper layer it is called the Cl or lower layer it is called the sima. So lower layer continuous layer composed by the common black volcanic lava. This is the common black volcanic lava. It is called basaltic rock. Which kind of rock? Basaltic rock. Okay. And this is the rich in silica and magnesium. Just like which is in the silica and aluminum. Same like it is the silica and magnesium. Si silica, Ma magnesium. Now talking about the crust is thickest beneath the mountain. So where it is the thickest? Obviously because the mountain thickness is very high, that's why it is the thickest position in the mountain, and thinnest under the ocean. In the this is the ocean, and the layer is very thin. So that's why it is the thinnest at the oceanic and thickest at the thickest at the mountain. Almost uppermost part is continuous of the sedimentary rock, and the uppermost part it is composed of the sedimentary rock. Now just like you have studied in the earlier classes about the atmosphere, just like in the atmosphere there are some pores, menopause, I think you have studied. Okay, same like that there is a discontinuity. It means there is a thin layer which separate these three layers: mantle, core and crust. So is Mohoro-Visick discontinuity. This Mohoro-Visick discontinuity, it is the boundary between the crust and mantle. Just like see, this is the crust and this is the mantle. So there is a thin layer, there is a thin part in between this both layer, crust and mantle. Crust and mantle. So this thin layer is called the Mohoro-Visick discontinuity. Who discovered? It discovered by the Edreza Mohoro-Visick in 1909. He is from the Yugoslavia. Okay, and this layer is not uniform from 8 to 32 kilometers. Definitely, because if the uh, earth crust is not even, so definitely their Mohorovic discontinuity layer is also not it is also not continue. Now we are talking about the next layer. It is called the mantle. What is it called? Mantle. Basically this mantle is the second layer. What is it? It is the second layer. You know very well. The first layer is the crust, then second layer it is the mantle. A layer between crust and core. Definitely what is it? It is the layer between. Now see, if you see the structure of earth, now this is the earth, this is the earth crust, and here it is the core. Okay, crust, mantle and core. So you can see that it is the boundary between. Now it is a mantle, here it is the crust and core. So it is in between is the crust and core. So I hope it is clear. So boundary marked by the Mohorovic discontinuity and lower Gutenberg discontinuity. Now the boundary in between the crust and mantle, there is a Mohorovic, and same like the boundary between the core and mantle, it is the Gutenberg. That's why it is the area, it is in between the Mohorovic discontinuity and Gutenberg discontinuity. And its depthness, the mantle depthness is 35 to 2900, because up to 35, up to 60 kilometers, as I told you, is the crust. So definitely from 35 or from 60 there till the 2900 kilometers, there is a depth of mantle. Now see, thus you can also see that this mantle is also, because the mantle is very longest. Just remember, okay, the crust, mantle and core, out of these three layers the mantle is the thickest layer. The mantle is the thickest layer. That's why it is divided into two parts also. The upper mantle, which is also called the asthenosphere, and it starts from Mohorovic discontinuity till the 700 kilometers. Okay, its depthness is from Mohorovic discontinuity to the 700 kilometers, and it is cooler. But cooler does not mean it is very cooled. Cooler it means as compared to the upper layer. As we come from upper layer, it means from the crust to mantle, or then mantle to core, the temperature increases. Okay, the upper it is partially molten, but remember this asthenosphere, the upper mantle is little bit viscous in nature. That's why you have studied in last chapter, it is the molten magma. So this molten magma, it is the part of this upper mantle, which is also called the asthenosphere, and made of a solid rock. Basically there is having a solid rock also. Now the lower part of this layer, it is called the mesosphere. Yes, don't confuse, mesosphere is also in the atmosphere, but here is also upper layer of mantle is called asthenosphere, and the lower part of mantle is called the mesosphere, and it extends from 700, because up to 700 there is a upper mantle. So definitely from 700 to 2900 kilometers there is a lower mantle or the mesosphere. It is hotter and denser than upper layer, obviously, because as we move from upper layer to inner layer, the temperature is increases. That's why it is hotter as compared to the upper layer, and it is denser because solid due to the high pressure, because the pressure is increases, so that's why it is solidifying, because of the pressure is increases, and it is denser. Okay, now layer is composed of magnesium. Basically what is it composition? So layer is composed of magnesium, iron and silicates. Magnesium, iron and silicates. What is it composed? Magnesium, iron and silicates. At the depth of around 100 to 410 kilometers, mantle is partially molten, which I already explained you. It is in the upper astrosphere, which is partially molten state. From where? But you remember, from 100 to 410 kilometers. In that area, there is a magma chamber, because this astrosphere upper layer, mantle, this layer is partially molten state. This layer is the this layer is partially molten, so that's why it is in liquefied state. Okay, it is in the liquefied state. Then the pressure increases towards the interior of the earth. Already told you, as we move come from upper layer to inner layer, so temperature as well as pressure is increases. Okay, so pressure is increases toward interior of the earth, density also increases. Yes, density, pressure, temperature, these all are increases. Temperature varies from 100 degrees Celsius to 1900 degrees Celsius. What is the temperature of mantle? From 100, from 1000 degrees Celsius to 1900 degree Celsius, or 1900 degree Celsius. I hope it is clear. And the last one, it is the Gutenberg discontinuity. I think it is clear, but again, let me clear you. We have discussed this is earth crust above, this is the mantle, and center one is the core. So there is a thin layer in between the mantle and crust. It is called Mohuru. Same like that, there is a thin layer between the mantle and core. It is called the Gutenberg discontinuity. So it is the boundary between the mantle and core. I think it is clear. It begins at the depth of 2900 kilometers. Definitely, why? Because till 2900 kilometers the mantle is over, mantle is finishes. That's why the Gutenberg is situated at the 2900 kilometers position. Then abrupt changes in the seismic waves. In the in the first introductory part, we have discussed about the seismic waves, because we studied this all interior part of the earth due to these seismic waves and volcanic eruption part. Okay, so what are the changes? First is the P waves, decreases in velocity. As we go inside in Gutenberg, at the Gutenberg position, what will happen? The velocity of P waves is decreases, and the AS waves is completely disappear. Why? Because in the center it is a solid state. That's why we remember, if you remember, AS waves does not pass through the solid. So that's why it disappears, it stops transforming from the this Gutenberg discontinuity. It is dense due to the greater percentage of iron. As we go inside, so silica, magnesium, aluminum composition is lower, and the increasing of the iron percentage is the percentage of iron is increases. Okay, so that's why their density is high. So I hope it is clear. It is not that much difficult. If you go through these points, it is very easy to remember, because in the earlier classes you have already discussed or studied. Only you have to remember some data, which is I'm already given in very short. You can note it down and you can learn very easily. I hope it is clear. In the last or in the next module, we are discussing about the last part, is the core, and also part of the revision part. So I hope it is clear. Have a nice day. Thank you so much.